Hey everybody, this is Mr. Collier coming at you with an extra credit assignment. And congratulations to all of my students who are able to solve this and get it right. I'm going to go ahead and do a solution video to show you how to do it. It says find all the real numbers x that make this equation true. So on the left side, I have 4, that's my base, and I'm raising it to the exponent 2x squared minus 7x plus 3. And on the other side, I have 8 raised to the x squared minus x minus 6 power. And I wanted to see if anybody could figure out what x would have to be. What numbers would solve this equation? So I have a hint over here that we're going to use. 4 is going to be equal to 2 squared, right? That's 2 times 2. And we have 8 is equal to 2 cubed, which is 2 times 2 times 2. So what we're going to do is we're going to replace this 4 with a 2 squared. So I get 2 squared, and my exponent is the 2x squared minus the 7x plus the 3. On the other side, I have an 8. I'm going to replace that with 2 cubed, so 2 to the third power. And we're raising that to the x squared minus x minus 6 power. All right, so now what I'm going to do is I'm going to use an exponent rule that's called the power rule. It simply states that if you have a number a raised to an exponent m, and then you take the whole expression and you raise it to the n power, you can multiply those exponents to get a to the m times n power. So what we're going to do is we're going to take this 2 right here. I'll go ahead and underline it in red. We're going to multiply that by everything on the outside, that exponent up there. And then over here on this side, I'm going to do the same thing. I'm going to underline the 3. That means multiply the 3 by the exponent, x squared minus x minus 6. So let's do this on both sides. So I bring down my base. That's going to be 2. If I multiply all this by 2, I'm going to get 4x squared minus 14x plus 6. All right, so I'm multiplying everything by 2 up there. On this side, I'm going to multiply everything by 3. So I get 2 to the 3x squared minus 3x minus 18. Okay. So now I've got 2 raised to a power is equal to 2 raised to a power. Since the bases are the same right here, they're both 2, what I can do is I can set the exponents equal to each other. So what I'm going to do is I'm going to set the 4x squared minus 14x plus 6 equal to the 3x squared minus 3x minus 18. So I bring that down on the left side. On the right side, I'm going to have 3x squared minus 3x minus 18. I want to get all the terms on one side now because I want to put the x squareds with the x squareds. I want to put the x terms with the x terms, and I want to put the regular numbers together. What I want to do is I basically want to get everything to the left side. So I have, whatever is equal to whatever number that shows up on the right side. And since there's nothing on the right side, it's going to be 0. So to do that, I need to make the right side equal to 0. To get rid of the 3x squared, I can subtract it from both sides. So I subtract the 3x squared from both sides. To get rid of the minus 3x over here, I can add 3x to both sides. And then the minus 18, I can add it to both sides. Let me draw that straight line. Okay, so what happens here is the x squareds cancel out over here, right? Because I have 3 minus 3. Over here, the x terms are going to cancel out, right? I've got negative 3x and a positive 3x. And then over here, I have negative 18 and positive 18. So everything's just going to go to 0 on this side. Over here, if I do 4x squared minus 3x squared, I have 1x squared. I'll just write that as x squared. And minus 14x plus 3x. That's going to be minus 11x. 6 plus 18 is going to give me 24. And now I have a quadratic equation I can solve. So if I can factor this, I can figure out what x is going to be. What I would have to do for this one is I would have to find two numbers that multiply to a positive 24, but add to a negative 11. So what are those two numbers going to be? 3 and 8, but to add up to a negative 11, they both have to be negative, right? So I'm going to get x minus 3 times x minus 8. And the whole thing is still equal to 0. So now I can make my two equations. I'm going to have x minus 3 equals 0. So I set the first factor equal to 0. And then I'm going to have x minus 8 equals 0. So those are going to be my two equations. To solve this one, I need to get x by itself. I can add 3 to both sides. When I do that, the negative 3 and the positive 3 cancel out, and I'm left with x is equal to positive 3. Over here, same thing, but with a different number. I have x minus 8 equals 0. To get rid of that minus 8, I need to add 8 to both sides. And I get x is equal to 0 plus 8. That's going to be positive 8. So those are going to be my two numbers that are going to be inside my solution set. I'm going to have a positive 3 and a positive 8. Okay, so that is my solution set. Now what I'm going to do is I'm going to check both of those to make sure that they work. So what I'm going to do is I'm going to check them, which means I'm going to plug both of them in and see if they work in the original problem. Okay. So my two numbers were 3 and 8, right? Yes, 3 and 8. And what I want to do is I want to plug them both into the original. And the original was 4 to the 2x squared minus 7x plus 3 is equal to 8 x squared minus x minus 6. So let's try the 3 first. Everywhere I see an x, I'm going to replace that with a 3. So I get 2 times 3 squared minus 7 times 3 plus 3. I get 3 squared minus 3 minus 6. Now with the exponent, I'm going to have 3 squared, which is 9. And if I multiply 9 by 2, I'm going to get 18. Now if I multiply 7 by 3, I'm going to get 21. Over here, the 3 squared is going to give me 9. That's 3 times 3. So I'm going to get 9 minus 3 minus 6. Okay, so these numbers are going to give me 0 when I add all the numbers up. And I get the same result on the other side. I get 0 as my exponent. So now I have 4 to the 0 power. Anything to the 0 power is going to be 1. So I get 1 equals 1. And that's my true statement. Okay, so that means 3 is going to work for this. 3 definitely belongs in the solution set. Now we're going to try 8. I want to try x equals 8. So here's my original equation. What we're going to do with this is we're going to plug in 8 everywhere we see an x. So I get 4 to the 2 times 8 squared minus 7 times 8 plus 3. On the other side, I get 8 to the 8 squared minus 8 minus 6. Eight squared is going to give me 64. 7 times 8 is going to give me 56. And I have that plus 3 at the end. Over here, I have 8 squared, which is 64, minus 8, minus 6. All right, so on the left side, I'm going to have 128 minus 56 plus 3. And over here, I'm going to have 64 minus 8. That's going to give me 56 minus 6. On the left side, I have 128 plus 3. So let's make that a 131. Then we have minus 56. We can make this 11. Take 1 away, so that's a 2. And then make it a 12 and take away the 1. So I get 75. Yep. So 4 to the 75 power. On the other side, I'm going to have 56 minus 6 in the exponent. That's going to give me 50. All right, so now what I'm going to do is I'm going to change 4 to 2 squared. So I'm going to do that over here on the right side. I know that 4 is the same thing as 2 squared, so do that. I've still got it raised to the 75th power. And then on the other side, I have 8, which is 2 cubed. What I can do with the exponents is I can multiply them. The base is going to be 2. 2 times 75 are my exponents. When I multiply them, I get 150. And then on the other side, if I multiply these exponents, I get 150. So I get the same thing on both sides. That is true. So 8 is going to belong inside that solution set. So 3 and 8.